Welcome you all in this new video, and today video is going to be very interesting because in this video we are going to discuss about the Bernoulli's theorem, what it is, and how we can use this Bernoulli's theorem in our real life. Okay, so this theorem is quite interesting, and if you want to know this actually what it is and how we can apply this in our real life. Okay, so this is our Bernoulli's theorem equation, and this equation is very important from daily life perspective because we use this theorem in our daily life. We experience this. Okay, so first of all, let me write the equation. What is equation? So after that we will derive the equation for this. Okay, so GH is equal to constant. So this is the expression of Bernoulli's theorem which we are going to derive. Okay, and this is very interesting, and we can say that this equation, on the basis of that equation we can explain all these applications. There are many applications in our daily life, but I have chosen only the few with which you are familiar. Okay, first is lift of an aircraft wing. We can say then when there is an aeroplane which is moving on a runway. Okay, while it was moving on the runway at a very fast speed, it get lift up, means there is something pushing this aeroplane upward. Okay, so because of it fly, it get lift up away from the that runway. Okay, so second one is blowing of the roof, means when you have observed that when there is very high speed wind, okay, flowing above the surface of the roof, what happened majorly we have measured that the roof get detached from the house body. Okay, so how this is happening, all these things are explained through the Bernoulli's theorem. We can easily explain. And third one is Bunsen burner. Okay, once you understand the Bernoulli's theorem derivation completely, and then you are easily explain able to explain all these phenomena, why aeroplane is lifting, what is happening when there is high speed wind flowing through the upper surface of the roof. Okay, so let's start the derivation of Bernoulli's theorem. Before we start the derivation, let's understand what is our consideration and approach. Okay, consideration and approach. What is the meaning of consideration? In the consideration we will consider what is the type of the fluid. Okay, what is the condition that we are going to apply there for the derivation of Bernoulli's theorem. Okay, so the condition is very simple. There is streamline flow. Streamline flow. What does this streamline flow means? Streamline flow of fluid, we can say. Okay, and fluid can be in any form. Okay, it can be in the gas form, it can be in the liquid form. Okay, so let's say this is our pipe. Okay, and here is point A and here is point B. So what does the streamline flow of fluid means? It means that the rate of the flow of the fluid with this pipe at point A is equal or same as the rate of flow of the same fluid at point B of this pipe. Means the rate of flow of the fluid with that pipe, that is constant. Okay, there is no any change in the rate of flow. It means that rate of change of the velocity of that fluid inside the pipe is 0, or we can say is constant. Means there is no any change in the velocity of that fluid while it was passing from that small piece of the pipe, this one. Okay, and this is first condition, this is our concentration. Now what is the approach that we are going to apply here? Okay, approach is very simple. We will calculate the force because of the motion of that fluid inside the tube, that particular small piece of the tube, that will be equal to the net force acting on the fluid, or we can say on the small piece of pipe because of the motion of fluid. So what does this motion means? Motion, let's say this is your pipe. Okay, and what is the net force means? Net force means what is the force acting on this face, and what is the force acting on this face, and what is the force acting downward because of the gravity. Okay, that is your weight. All these combination, okay, all these force combination, two forces on the surface on these faces, okay, and one force is because of gravity, that by combining these we get net force. Okay, and what about the motion force? Motion force is because of its velocity when it is passing from that pipe. Okay, So when it is passing from that pipe, what does this mean? What is the motion? Force motion, that is we know from the Newton second law of motion, okay, that is F equal to ma. So what is the acceleration? That is rate of change of the velocity. So this is your force because of motion. By equating the force because of motion with respect to the force, that is net force, okay, we will easily get the Bernoulli's theorem. Okay, so now approach is clear, consideration is clear. Okay, so now derive the equation. So let's first of all understand the diagram completely, and if your diagram is clear, then there is no any need to understand anything. Okay, from your diagram your equation get automatically clear. So this is our small piece of the, we can say, pipe. Okay, let's say it has length dl, okay, and have a similar or constant rate of cross section. Okay, that is, let's say, we can say what is the area of cross section, that is dA, and here is what is the area of cross section, that dA, means area of cross section of that small pipe is constant. Okay, so now what, let's say P is the pressure that is acting on this phase. Let's say this phase name is A and this phase name is B. Okay, P is the pressure which is acting at the phase A. Okay, so what will be the pressure that will be act at point B? Okay, so that will be P plus curly P over curly L dl. What does this mean? This is the small change, guys, with respect to the length. Okay, pressure is changing when it is flowing from A to B, and that small change in pressure, that is this. Okay, so this is your pressure that is acting on the phase B. Okay, so now what is the clear to us? Pressure and what is the length, and so let's say now what is the remaining is what is the height between, let's say this is your direction of the flow of the fluid. Okay, so let's say height between A and B, okay, upper face and lower face. Okay, let's say height between upper face and lower face. Okay, lower face is touching the ground, and what is the slope? And because of that slope there is difference in the height between the face A and face B. Let's say that height is small height dh. Okay, this is dh, and let's say this angle that is making here, okay, that is, let's say, theta. So now what is clear to us? What is the height difference, and what is the area of cross section, and what is the pressure acting on the different faces, and what is the length? Okay, now one thing is remaining, that is our, we can say that is the we can say its weight. Okay, its weight will be downward mg, and we know that any force component, any force, they have two components. So here also the gravitational pull, we can say the force because of earth gravity, it also have two components. One component is along the direction of motion of the fluid, that is mg cos theta, and one component is in the perpendicular. Both cos theta and cos sine are perpendicular to each other. Okay, so here is also mg sine theta. So we will consider only the component of that force which is along the direction of the fluid, means we will consider force component, which one? mg cos theta will be considered when we will calculate the net force. Okay, so what are the things clear? Okay, we have clear the force because of gravitational pull, and pressure is clear, height difference is clear, length is clear, and now one thing is remaining, that is the mass. What is the mass of that fluid at a particular instant of time in that we can say in that small piece of pipe? Okay, so what is the mass? You know that mass is what? Volume into density. So if we calculate the volume is dA is the area of cross section, and dl is the height, and rho is the density of that particular fluid. So this is the mass. Now applying the equation, force because of motion, okay, and is equal to net force. I told you net force is the combination of the force acting on A and force acting on B plus force because of the earth gravity. Okay, so it will be equal to what? Let's say what is the force acting at face A, that is PdA, okay, minus what is the force acting on B. Why I am putting minus? The reason is there because there is decrease, or we can say we have to calculate the net pressure on the face. Okay, because here is different face, okay, A and B, so we are calculating net, so we are neglecting the pressure, okay, from with respect to the pressure A, or we can say force acting on A. So here will be P plus curly P over curly L dl, okay, area of cross section is constant, plus mg cos theta. So now you are thinking, what is the cos theta, from where we will get the cos theta? A, B, let's say this point is C, okay, from triangle A, B, C we can easily get the value of cos theta, that is equal to dh over dl, okay, dh is your base and dl is hypotenuse, okay. So dh over dl, so we can take it in negative because length is decreasing when the fluid is flowing from point A to point B, okay. So this is the cos theta value. So when we will calculate it further, so it will become d, you know, PdA, which is the force acting on A, that will be cancelled out here. I am putting it directly, so don't be confused. So here will be curly P over curly L dl dA plus mg cos theta, okay. So and what is the value of air in motion, that is mass into dV over dt, okay. So this is the expression that we got. Now calculating the further or deriving it further, what we will get, what is the force because of motion, that is m dV over dt is equal to minus curly P over curly L dl dA minus mg, I am putting the directly the value of cos theta, okay, that is dh over dl. So now what is this value, dV over dt, how we will get? I am putting directly dV over dt is equal to V curly V over curly L plus curly V over curly T. Now you will ask, from where we will get this equation? So we know that the velocity of the fluid in this case is the function of length and time, means velocity is changing. We are assuming it. Don't think that we had assumed that streamline flow. We didn't apply yet the equation of or a condition of streamline flow. So don't be confused. First of all, we will generalize the equation. Here we are considering what velocity is changing with length and time, okay. We will apply the streamline consideration, okay, streamline condition to derive Bernoulli's theorem, okay. That is the next step. So here we are generalized equation. We are thinking that okay, velocity is changing with the time and length, okay. We will apply the streamline flow. So by applying the streamline flow there, we will get the Bernoulli's theorem. Just look at here, okay. So this is the velocity with respect to, so how we can write this? We can write this like dV over d curly L plus curly V over curly T or dt, okay. So by differentiating this velocity with respect to the time, we will get this equation, okay. So it is very easy. So here what is the mass, so what is the value of dV over dt, that is curly V over curly T plus curly V over, sorry, there is curly L, this is curly L, okay. So this is curly T is equal to minus curly P over curly L dl dA minus mg dh dl, okay. So now we will apply the streamline flow by applying streamline flow condition. What is the meaning of streamline flow condition? It means that dV over, sorry, curly V over curly T, okay, means the rate of change of the velocity with respect to the time, it will be 0. By putting this condition in this equation, we will get, okay, I am putting it directly, so don't be confused. So we will get V dV, okay, plus dP over, okay, I am also considering the mass, I am putting the mass also here, okay. You know that what is the value of mass that we have got in the early of this video. So that was dA dl, okay, and rho, that was the density, okay. So this is the equation that we got. So here is plus G dH is equal to 0, So this is the equation that we have got. This is the equation for only a small piece of the pipe. Okay, if we have to calculate the equation for whole or generalized equation, so what will be? By integrating the equation. Okay, what we can say, by integrating the equation. Okay, when we will integrate the equation, what we will get? 1 over 2 v square plus p rho plus gh is equal to constant. So this is the equation I was talking earlier or in the first slide of this video. So now on the basis of this equation, what does this say? This says that if your height is constant, height is not changing, okay, we are assuming that. So what does this mean? Velocity plus pressure will be constant. Okay, it means that if in a particular region your velocity is increasing, it means pressure will decrease. Okay, for example, there is two regions connected with each other. Okay, in first region, if the velocity is increasing, and what does this mean? It means that in the second region velocity will decrease. If and velocity is increasing in the first region and pressure is decreasing, it means that pressure will increase in the second region. Okay, for example, understand this through the diagram or the example or application we had in the early of this video. So this is your house. Okay, this is your roof. Okay, what is happening? There is a very strong wind. Okay, very strong wind above the surface of the roof. Above the surface of roof, what is the velocity of that wind? Velocity wind is very high. And I told you, whenever there is velocity very high, this according to the Bernoulli's theorem of this equation means your pressure and velocity should be constant. What does this mean? Pressure velocity should be constant means if your pressure is increasing, velocity will decrease. Okay, so velocity is increasing, it means pressure is decreasing. I tell you, the region which is connected with this region means below the surface of the roof, what will happen? Velocity will decrease and pressure will increase. When the pressure below the surface of the roof is increasing, because of which it push the roof upward and roof get detached from the house. Okay, on the basis of such explanation you can easily explain every phenomena which is related with the Bernoulli's theorem. I hope you like this video. If you like our video, then give a thumbs up.